the degrees. Yeah, fill those in with the degrees and radians. Any extras of these? Okay, so we have 0 degrees right there. What else do we have right there? 360. Yeah. What do we have straight up? 90. And then 180. And then the bottom is 270, like we said. And so in radians, this would be 0 and 2 pi. And we just said this on during the warm-up, so I'll just write them here. So we have pi over 2, pi, 3 pi over 2, and 2 pi. Okay, so we're going to introduce this idea of what's called a reference angle. So I'll show you what a reference angle is first, and then we'll read that sentence there. So if I sketch a graph of 150 degrees, which looks like this, the reference angle is 30 degrees. And it goes right there. You can see by the picture. So a reference angle is the positive acute angle. What does acute mean? Yeah, technically it's not just less than 90, it's less than 90 greater than 0. Yes, very nice. So the reference angle is the positive acute angle formed by the terminal side and the x-axis. So here's our terminal side. Here's the x-axis. Our reference angle is 30 degrees. And this 30 degrees doesn't have a direction to it. It's not like opening. We don't need to draw an arrow. We're using it as a reference. So stuff about 30 degrees will also tell us things about 150 degrees, just in a slightly different way. Another way to think of this, instead of this definition, is it's the related first quadrant angle. "30 degrees, the angle itself, is in the first quadrant, and 30 degrees is our reference angle for 150. So there's just two ways to think about it. Okay, so for 315 degrees, that's here in the fourth quadrant. Our reference angle would be this angle right there. And we just measure that in positive degrees. So it's not a negative angle because it's going down. We're just measuring that like we would in geometry. Turn to your neighbor. What would that be? And how do we know? Okay, so what would the reference angle be? 45 degrees, yeah. And so we can find that by doing 360 minus 315 to see basically what's left over. So sometimes we might just need to do a little bit of math to figure that out. The same thing also works in radians. So 5 pi over 3. What is 2 pi in thirds? 6 pi over 3. So we're 1/3 away. So 5 pi over 3 is right there. And the reference angle that I said was, I actually just gave a hint. How far are we away from 2 pi? 1/3. So our reference angle is pi over 3. 1/3 pi. Okay, you guys do the rest of those. Okay. What quadrant is negative 240 in? Second quadrant? Yes. Positive 240 would be in the third quadrant, so we can find that by reflecting. I guess this one would overlap too. Remember, our reference angles always are made by the terminal side, which is just like the side of the angle, like the one that's pointing to negative 240, that's the terminal side. The terminal side and the what? Make the reference angle. And the x-axis. Okay, so we're always going down or up to the x-axis, wherever it may be. And we're measuring that in degrees or radians. So how many degrees does that angle measure? Negative 30? Mm-mm. How many degrees would that be? It's always positive, one thing. This would be 60 degrees. So it's the distance between 240 and 180, which is 60. This would be 30 degrees, right? Because that's negative 270 at the top. Those are 30 apart. We're going down to the x-axis, so that's 60. Okay, 7 pi over 6. What quadrant is that in? Okay. 7 pi over 6, what quadrant are we in? Show me on one hand. Yes, third quadrant. So pi would be 6 over 6. This is 1/6 more. So even there, that's the hint. What's our reference angle there? Pi over 6. It's just the distance between that angle and the quadrant. What quadrant, and the x-axis, sorry. What quadrant is 5 pi over 4 in? Or negative 5 pi over 4? Is in the second quadrant. Yep. Positive 5 pi over 4 is in the third quadrant. We can reflect. So then that distance right there is how much? Pi over 4. Okay. You can do these as extra practice right there. It's basically just doing the same thing. Okay. We are going to use these reference angles to do a little bit of trigonometry, just like we did in geometry. So this is going to be a little flashback here. If you guys remember the abbreviation SOHCAHTOA, this tells us that, it just says it right here, but sine is the ratio of the opposite leg to the hypotenuse. Cosine is the ratio of the adjacent leg to the hypotenuse. And tangent of an angle is the ratio of the opposite leg to the adjacent leg. All of these are from theta's point of view. So in that triangle right there, what side is opposite angle theta? What side is adjacent to angle theta? And what side is the hypotenuse? Okay. If we change theta to the other side of the triangle, now 3 is opposite and 4 is adjacent. So it's always from the point of view of the angle. That's what's important. So fill out these 3 from the triangle. Ready, set, go. Okay, so sine of theta would be 4 over 5, cosine would be 3 over 5, and tangent would be 4 over 3. So those are the 3 main trig functions that we learned in geometry. We're going to learn 3 more because there's actually 6 total. CSC stands for cosecant. And what cosecant is it's the reciprocal of sine. So that means cosecant equals 5 over 4. The next one is secant. Which is the reciprocal of cosine. And so it's 5 over 3. And COT stands for cotangent. And that's one of the only names that makes sense here, but that's 1 over tangent. So it's 3 over 4. And here's a little chart here for you to remember that. But we're going to use these a lot. I know they're brand new right now, but we're going to use these so much you're going to get really familiar with them. And we'll practice with them a lot today. So I know it might be a little strange or counterintuitive that sine goes with cosecant and cosine goes with secant instead of the other way around. But first of all, I didn't make these up, so sorry. But what I like to remind myself is there's 1 co per row. So there you go. First row is sine and cosecant, so we need a co. Second row, we need a co there, it's cosine and secant. And then tangent and cotangent. So if that helps you remember, great. That's not why they're named that way. That's just how I remember.
Do you know why they're named that way?
Yes. It has to do with when we go to geometry and we have a radius and a tangent line. They form a right triangle. And so if the angle is there, the tangent line and the radius, that's the opposite and adjacent side. So that's like why tangent is opposite over adjacent, because it's the tangent line and the radius. And then this is a secant line right here, because it goes through the circle 2 times. That's something we learn in geometry. The secant line, this part of it right here, to the radius, so hypotenuse over adjacent, becomes the secant ratio. And so we had like a tangent ratio and we had a secant ratio. And I think, I'm trying to remember how sine and cosine fit into this. So it's like that secant was basically created as the reciprocal of cosine. It's hypotenuse over adjacent. So I think I need to go back and look up where the sine and cosine come from. But I know it's basically originates from this. Yeah. It is. No, it's interesting. It's interesting to me. Okay. So, I changed this on yours. On the xy plane, where radius equals r, and I added these here for you guys. So theta represents reference angles. Which, so that means it could also, theta could be there. Well, we don't need the circle anymore. Theta could be there, or theta could be here, or theta could be here. So just like reference angles, theta is always touching the x-axis. So because theta is always touching the x-axis and is at the origin, so theta is always in that position right there, and it could be like this, or like this, or like this. Then that means the sine ratio when we go to the coordinate plane is always y over r. Y is going to be the y coordinate of this point right there. That would be the point xy. And the sine ratio would always be y over r, because that's opposite over hypotenuse. Cosine is always going to be x over r. Tangent is always going to be y over x. And cosecant is the reciprocal of sine. Secant is the reciprocal of cosine. And cotangent is the reciprocal of tangents. So we're going to do a few examples with this on the next page. Okay, so if we're using the coordinate 2, 5 to find these values, what we need to do is we need to sketch the reference angle. So we plot the point 2, 5, which would be roughly there. And our reference angle is going to form this right triangle right here. So again, it's always going to touch the x-axis and it's at the origin. So a common mistake sometimes is to draw our triangle like this. That's not correct. If I put theta right there, it's not touching the x-axis, it's touching the y-axis. Since that point is 2, 5, that means we went over 2 and up 5. So those are the two sides of our right triangle, the two legs. And then how would we find the hypotenuse? Exactly. We'll say that's r. 2 squared plus 5 squared equals r squared. So 4 plus 25 equals 29. Which is r squared. So our radius there is square root of 29. And now we can use that triangle to fill out sine, cosine, tangent, secant, cosecant, cotangent. So for example, sine would be opposite over hypotenuse, or y over r. That's 5 over root 29. And cosecant would then be root 29 over 5. Now the only thing we would want to do with sine is we want to rationalize it. So we're going to multiply by root 29 over root 29. You get 5 root 29 over 29. Okay. You guys use the triangle to fill out the other 4. Ready, set, go. Okay, what's cosine unsimplified or unrationalized? 2 over root 29. Okay, so before you rationalize it, we know what secant would be. It would just be the reciprocal of this, root 29 over 2. Now we can rationalize, so we get 2 root 29 over 29. What would tangent be? 5 over 2. So cotangent is, yeah, it's just a reciprocal. Okay, nice. Questions on that? Okay, draw the triangle for example 2. Okay, so here's what it would look like. We plot the point -1 root 3. We put it in the second quadrant because that's where that point is. We draw our triangle so that the reference angle theta is touching the x-axis and is at the origin. We're going to label our sides here. So we have a triangle with sides -1 and root 3. In geometry, we never had negative sides. We're not in geometry anymore. So we can have negative sides. There's 2 ways to find the radius. One is we could do the Pythagorean theorem. If we do that, root 3 squared plus -1 squared. What's -1 squared? 1, right? So this is 3 plus 1, 4. Our radius is 2. Or if we recognize that that's a 30, 60, 90 triangle, we could do that a little faster. 1, root 3, and 2. That's our 30, 60, 90. But one thing I want to point out here is the radius / the hypotenuse is always positive. Because when we do the Pythagorean theorem, even with negative numbers, when we square them, they become positive. But this does mean that some of our values for sine, cosine, tangent are going to be negative. Like cosine is -1/2 because we have to use that negative x coordinate right there. Okay, you guys fill out the rest of these. Okay. We should get these as our sine, cosine, tangent, secant, cosecant, cotangent. Do we get those? Okay. Read this and turn to your neighbor. Where would we draw this triangle?
I just went back to it.
Okay, so we're told sine of theta is 4 over 5. We can't draw that right away. We need to figure out what quadrant this goes in. We're also told that theta is between pi over 2 and pi. What quadrant is that? That's quadrant 2. Because here's pi over 2. Okay. So here's my triangle to go with my reference angle right there. Okay, we're told that sine is 4 over 5. So we know sine and cosecant right away. But remember that sine is just the ratio of y over r. So that means that y is 4 and r is 5. That would make sine 4 over 5. What would the x coordinate be? So it's 3. This is a 3, 4, 5 triangle, remember from geometry, except we're in the second quadrant and we're going to the left. So is it 3? It's negative 3. So when we do the Pythagorean theorem here, if we need to, 5 squared minus 4 squared is 9. We take the square root of that, we get 3, but we have to make it negative. We have to know to make it negative based on where it is. And now we can fill out the rest of these. Okay, let's go to the next page. So, we're going to see some problems like this, basically where we're trying to figure out where these reference angles are. We don't know much about these angles, we just know like either sine is negative and cosine is positive. But we're trying to figure out what angle, what quadrant this angle must be in based on that information. So, the thing that we want to remember for this is our ratios here. So write these down with me. Okay, so remember that r is always positive. So in number 1, if we're told that sine is negative, and sine is y over r, and r is always positive, what does that tell us about y for sine to be negative? What do we know about y? Y has to be negative. So sine is only negative when y is negative. Which quadrants is y negative in? 3 and 4. Okay. If cosine is positive, what does that tell us? It tells us that x is positive. Because cosine is x over r. R is always positive. So if cosine is positive, x must be positive. Which quadrants is that true in? 4 and 1. So where are both of these statements true? Quadrant 4. So that's what we have to do. Each of these is going to give us 2 quadrants that the angle could be in. And we pick the one where they're both true. We pick the one where they overlap. Okay? If we're told tangent is negative, if tangent is y divided by x, what must be true in order for that to be negative? What's going to make y divided by x negative? What needs to be true about x or y? Turn to your neighbor, talk about it. Okay, so where tangent is negative, if tangent is y divided by x, it means that either y is negative and x is positive, or y is positive and x is negative. They can't both be negative because a negative divided by a negative is a positive. So this can only be true in quadrants 2 and 4. That's where x is negative and y is positive, or where y is positive and x is negative. I might have just said the same thing twice in a row. But that has to be quadrants 2 and 4. Okay, use those to answer the rest of the questions. Ready, set, go. All right, let's check. So for number 2, we said tangent is negative in quadrants 2 and 4. Where is cosine positive? Which 2 quadrants? Two and 4? Where's cosine positive? 4 and 1. Okay, so they overlap in quadrant 4. Number 3, if cosecant is positive, then what variable would be positive? Y. Okay, and then for cosine, that means x is negative. So y is positive in 1 and 2, x is negative in 2 and 3. This one is in quadrant 2. If secant is negative, that means x is negative. If cotangent, so that's 2 and 3. If cotangent is positive, that means either both x and y are positive or both negative. It's the same as tangent. That's in quadrants 1 and 3. So those overlap in quadrant 3. Okay, so when we get to example 4 here, turn to your neighbor, what quadrant is this going to be in if we know that cosine is negative 12 over 13 and tangent is negative? Okay, this is going to be in quadrant 2. If cosine is negative, it can be in one of those. If tangent is negative, it's in one of those. So they overlap in quadrant 2. What would the x value of this triangle be? Negative 12. And our hypotenuse would be 13. That's where we get these numbers from. Do you guys remember the triangle with 12 and 13 as the sides? 5 is the third side. Okay? Just go ahead and memorize 5, 12, 13. 3, 4, 5. That way you don't have to do the Pythagorean theorem with those. 7, 24, 25 is one. 8, 15, 17. Yeah, there's a few. Okay, would 5 be positive or negative? Yes, it would be positive. It's going up. It's the second quadrant. It's the y-coordinate. And so we could fill out our triangle from here. Draw the triangle for number 5. Okay, so what we're seeing here is that secant is negative. This means that x is negative, so we're in quadrant 2 or 3. Sine is positive, so we're in 1 or 2, so we must be in quadrant 2. If I look up at the top there, I am reminded that secant is the ratio of the radius over the x-coordinate. So if that's negative 2, how could I represent that as a fraction? 2 over 1. So if secant is negative 2 over 1, what is my radius going to be? Is it going to be 2 or negative 2? Can the radius be negative? No, it can't. So the radius is 2. That means x is negative 1. That's how we get negative 2 for our secant value here. If we recognize this triangle, it's the same one from the page before, but it is a 30, 60, 90 triangle. So that would be root 3. And we can fill out the trig values from there, but actually the key that I want to focus on here is drawing the triangle correctly. Remember, theta, our reference angle, always needs to be touching the x-axis. So make sure it's always in that bottom right corner there. Okay.